Okay, hi, Assalamualaikum. So today our group will present our project on four-level elevator system. So a little bit of background study. Elevator are now a standard feature in modern building due to population growth and urbanization. Some new technological advancement in elevator include regenerative drive, destination control system, and also new sensor to enhance the elevator performance and also energy efficiency. The future trend currently include integration with smart building technology for automation and also improve user experience, while challenges also remain in retrofitting older building and also addressing the safety concern for older model. We believe that elevator will play a vital role in sustainable building practices by reducing energy consumption and operational work.
Assalamualaikum, my name is Lufian Sif, and today I will be discussing regarding the project's problem statement and the objectives. There is a requirement for the creation of a sophisticated mechatronic system that incorporates the programmable logic controller, the PLCs, to enhance the efficiency of the four-level elevator system. In terms of utilizing the innovative technologies like regenerative drives and destination control systems to enhance the operational performance and energy efficiency of the elevators. And lastly is to incorporate the smart building technologies to automate the process and that improve the overall efficiency for the users, as well as enhancing the efficiency of the elevators by reducing the energy consumption, operational expenses, and ensuring the safety while also adhering to the sustainable building practices and green standards. In terms of the objectives, the first objective is for us to develop the block diagram and process flowchart of the programmable logic controller, the PLC, based on the four-level elevator system. The second objective is to develop the comprehensive formation of a programmable logic controller ladder diagram for a four-level control elevator system that integrates sensors, actuators, motors, and computing that optimizes the performance and the efficiency of the system. Lastly is to determine the most suitable sensors and actuators and motors that can be used for the PLC based for elevator floor system with the implementation of a weight decision matrix, the application of design as well as the economic consideration.
Hi, I'm Aidil and we're moving on to literature review. So, elevator system is a vertical transportation in a building. With elevator or lift, user and building resident can make a vertical movement safer, quicker and easier compared to stair. Until now, elevator system is continuing being researched to make advancement in all aspects. Historically, first elevator system used a manual system where the lift cabin are being pulled by a person. Then, when electricity is introduced in 19th century, first electric elevator system is invented by Otis Company. Today, most of elevator system is developed to be a good energy efficient system. So next is smart elevator. Smart elevator is a PLC based elevator. The system enhance the reliability and performance of the elevator with minimum waiting time concept. Most of smart elevator system consists of sensor component and fully automated.
So what is PLC? PLC is basically an industrial computing device which is utilized for overseeing inputs and managing outputs. It is so that it can automate machinery or processes according to its program logic. So it employs programmable memory so that it can store instructions internally, so that it can execute specific functions via digital or analog components, as well as performing arithmetic operations to regulate functions like logic sequencing, timing, and counting. So for the PLC hardware, it consists of these components. As you can see in the diagram, there are the central processing unit, the CPU, the system buses, the memory, the I/O sections, the power supply, as well as the programming device.
Now, I will be discussing the methodology aspect of the overall project, where the block diagram is discussed in terms of the PLC-based four-level elevator system project. In terms of this block diagram, there are five main components of the whole system. The power supply, where it powers the PLC controller, the motor driver, and the motor. And secondly is the motor itself, where it is used as an actuator to move the elevator cabin up and down. The motor driver, which is basically connected to the motor, where it is transferring the information of the PLC controller to the motor itself. And the programmable logic controller, where it is a device that is used for the programming aspect of the system, as well as the elevator cabin, where it is used to store the people and transport the people up and down, where in terms of between the elevator cabin to the PLC controller, there will be also proximity sensors and door sensors, which is connected for each level of the floor that is required for level 1, level 2, and level 3, and level 4, which will be input into the PLC controller as well as output for the elevator cabin itself.
Okay, so this is our ladder diagram. There are a few components which can be classified into few groups. The first group is the switch. We have the first floor, second floor, and third floor switch. The second group is the internal relay 1, 2, and 3. The third group is the sensor. And lastly, we have the motor going up and motor going down. For the first group, the switch, it is for the user to choose which floor he wants to go to. The secondly, the internal relay, it is to send the information from the switch to the motor so that it can go up or down. Thirdly, the sensor, it is to detect which floor it is currently on. And lastly, the motor, after receiving the information from the internal relay, it will either go up or down. We also have another special feature for this elevator, which is the maintenance switch, in which when pressed, it will go to the basement floor so that we can do maintenance work on the elevator.
Okay, now I will demonstrate our 4-level elevator system. So for the first case, where the user will push the first floor button, so it will turn on and also activate the internal relay 1. Internal relay 1 will latch itself, so the connection will stay connected, and in the round 5 it will send signal to the motor to going down. And when the lift cabin will reach the first floor, it will be detected by a first floor sensor, and when the first floor sensor is activated, the motor will stop going down. So that's the first case. And next, for the second case, where the user push the third floor button. So when the third floor button is being activated, internal relay 3 will activate it and also will latch itself, so the connection will stay connected. And in round 4, it will send the signal to motor to send the lift going up. And after the lift cabin reached and detected by third floor sensor, the motor will stop going up. So that's the second case. So in next case, where the user push second floor button, it will depend on the lift cabin position. So first I will turn on the first floor button. So the first floor button will activate, second floor button will activate the internal relay 2, and internal relay 2 also, as first floor button and third floor button, will latch itself, so the connection will stay connected. So depend on the lift cabin position. So if the cabin is on the first floor, so first floor sensor is turned on, the motor will going up. If the floor cabin lift cabin is on the third floor sensor will turn on and it will signal the motor to going down. So that's how second floor button work. And the last case, if the operator want to go to the maintenance floor at the basement, so when the maintenance button is being pushed on, So it will activate the base and send the motor going down to the basement. So that's all for our system.
Now, in terms of the discussing the process flowchart of the overall system of the programmable logic controller based floor level elevator, we will first assume that floor 1 is basement, floor 2 is ground floor, floor 3 is first floor, and floor 4 is the second floor. Where first we will begin with the user inputting the required floor level using the button 1, button 2, button 3, or button 4, and afterwards the power supply will turn on all of the motor and all of the sensor for the elevator system itself. And afterwards, the sensor 1, 2, 3 for each floor will detect, and it will detect the position of the elevator itself, where it will determine whether is the elevator cabin on the right floor based from the user's input. And if it's yes, then the motor does not turn on and the door will open and it will just end. But if it's no, then there will be another programming in the PLC where is the elevator cabin below the desired floor, whether the sensors that are detected between the sensor 1, sensor 2, and sensor 3, and it will determine whether it is above the desired floor or is it below the desired floor. And if it's yes, above the desired floor, the motor that goes up will execute, and afterwards it will end. And if let's say it is a no, then the motor down will execute, and then it will eventually leads to an end, which shows and explains the overall flowchart of the process of our project system.
Moving on with the results and discussion. So first we make the morphology chart for the decision-making process, in which there are four main features, which are the control system, the sensors, the actuators, and the motors. For the control system, there are three options, which are the PLC, the microcontroller, and the PC, in which we have decided that PLC is the best option because it is more reliable, flexible, and has better integration. It also offers extensive diagnostic features, which make it easier to troubleshoot and maintain elevator systems. Secondly, we have the sensors, in which the options are the inductive proximity sensors, the optical sensors, and the pressure sensors. And we have decided that the inductive proximity sensors is the best because it has a good accuracy and also low cost. And for the actuators, we have the cable actuators, the pneumatic actuators, and the traction actuators. We have decided that the cable actuators is the best because it offers a good balance between performance, cost effectiveness, and energy efficiency. It is also suitable for low to mid-price buildings. And lastly, for the motors, we have the geared traction motor, screw-driven motor, and the hydraulic piston motor. And we have decided that the geared traction motor is the best because it is the cost-effective alternative to gearless systems. It also provides efficient vertical movement, and it is suitable for elevators serving medium-rise buildings. For the weighted decision matrix, there are 5 criteria that we consider for the design, which are the cost, the suitability, the longevity, the performance, and the power consumption. As for the weightage, we spread the weightage accordingly. And then for the rating, we have the rating from 1 to 3, which is from poor to good. And based on the rating and the scores, we have selected the option 1 because it is the most suitable for our project.
So for our final result, we have designed 3-level system elevator with 1 additional maintenance floor. The 3 floor for public use, and the maintenance floor located at the basement is only accessible to operator for lift maintenance purpose. So the main component of the system is floor sensor, floor button, lift cabin, and motor. Each floor will be equipped with a floor sensor and push button. Floor sensor is used in the system to detect the current location of lift cabin and as guide for PLC to navigate the movement of cabin. And the motor is used together with actuator system to move up and down the lift cabin. For flow sensor, we have chosen inductive proximity sensor, which is highly sensitive and require no contact. And we also use gear traction motor and cable actuator to move the lift cabin, which can offer smooth and reliable operation.
For the application of design and economic consideration, space utilization is key. The design should maximize space utilization. For a four-floor elevator system, a compact design is essential to ensure minimized space consumption while accommodating the most space for its components. Designing for ease of maintenance and reliability is crucial to minimize downtime and repair costs. Using high-quality components and incorporating predictive maintenance techniques can identify and address potential issues before they escalate too quickly. For an elevator system, high foot traffic, and a high floor will cause a lot of problem in the later run. In summary, the project will be focusing on making a four-level elevator system using PLC to enhance its performance and reliability. In the system, there will be a ladder diagram for floor selection and a maintenance switch just in case for emergency repairing tasks. Despite having 4 floors, our floor 3 is only used for commercial use and the last floor will be used for maintenance. The recommendation involved for this project is to make a motion control system with the PID controllers. The PID controllers ensure smooth elevator movement considering factors like speed, acceleration, and passenger comfort. The PID algorithm are proposed to adjust speed and limit errors and dampen velocity change, providing a smooth riding experience for the building occupants and customers.
So that's all from us. Thank you.